two channel PWM signal generator module. Uh, in this module, we can vary both the frequency and the duty cycle, and we can use this both the output of the channel at a time. Um, I I have bought this module from a website called Popo.in. So let's go to the video. So after giving the necessary connections such as input to the module, and I have connected the channel 2 of this module to this oscilloscope for checking it. So let me turn on it, and you can see that now it can use this setup button to choose the mode to it. So now it displays this. So if you click on the setup button, it shows FA1 is to choose the frequency of channel 1. Now since we are in channel 2, we have to click again and again to go to FA2 to change the frequency of channel 2. And now the current frequency is 352 hertz. So if you want to change it, you have to use this up and down button to verify to change it. I have now I'm going to decrease the frequency. Let me wait for it. Actually, I'm increasing the frequency. Now so now the current frequency is 569 hertz. If you see my oscilloscope there, you can see that yeah, it's nearly equal to what I have been displayed here. Since it's cheap oscilloscope, there will be some minor variations. If you want to vary the duty cycle of channel 2, you have to press again the duty setup button and DU2 for to vary the duty cycle of channel 2. Now the duty cycle is 59 percentage. I'm going to increase the duty cycle to, let me zoom out the settings. Okay, now you can see that duty cycle is 43, and even in the oscilloscope also you can see it's 42.6. So if you vary that, you can see the waveform is varying very much. um, so like this way you can vary the parameters using these three buttons. So to control the module, we have used these buttons, but we can also do this via the by another microprocessor, uh, via the serial communication pins. So this module has extra three pins up there: ground, transmit, and receive. You have to connect these pins to the transmit receive pin of the or you can use this serial monitor library, and you can customize the pins in the to connect the receive and transmit. This programs allows you to control this module via the serial commands. So the serial commands has to be in a certain format. So this is the format it should be. For changing the frequency, it should be first the channel 1 F and XXX. If it be in a range of kilohertz, you have to use XX dot X and T. So these are the format of the format of the serial command should be like this. So you compile the code and upload it, and you can see take some time. the code has been successfully uploaded, and you have to open the serial monitor and type the command as it is. Now I have to change the frequency of channel 2 to 400 hertz. So yes, to F. Now if you enter it, yeah, as you can see, it replaces down. If it replaces down, it means that the code has been successfully executed. The command has been successfully executed. As you can see, the display changes to 400. So, now for another sample, I'm going to change the as you can see, if I press enter, the display changes to 900 and the response also given at down. So this command is successfully executed by the module. Um, now, if you want to send a duty cycle, the command should be proper, in the format. So I have changes the duty cycle to 90 percentage. So as you can see, the duty cycle changes to DU2 to 90 percentage. So if you send the commands improper way, it may show you down response. You can see it says fall. It says the fall as the serial command is not the proper format. So this is the one way. But the thing is, if you want to use any potential meter or encoder to vary this, you can modify this program. But I also have a simple. So there's an alternate program to vary the parameters of this module. So the thing is, uh, since the module accept only the data format in a form of ASCII, we have to send the ASCII, everything is an ASCII value. Since the serial communication in Arduino default sends the data in ASCII when we include it as double quotes, there's no problem in doing it. But in case of you have to vary in a form of a potentiometer or an encoder, then the variable type should be it's not a constant one. It be a varying. So whatever it means, you have to add plus 48 to the number you have to send it, because in ASCII value the numerical value starts only at the decimal point above 48. So 0 is 45, 0 is 48. So whatever number you do, just add 48 and just insert the integer here in the right function. Now if you upload the code, you can expect that module to have a output frequency, channel 2 output frequency as 200. The code has been compiling, is uploading. As you can see now, you can see the display changes to 200. Now the frequency is also changed to 200. So by this way, you can vary the parameters of this module. And another drawback of this module is it sometimes turned off automatically. Maybe it's some kind of fault inside them, but I don't know. But it sometimes the serial commands it halt and it stops to it does not respond to the serial commands suddenly, and it's also sometimes turned off automatically without uh, any display or something. That's some kind of faults where you can see this module. Other than that, this cheap module you can also use in many applications, like just to, to make a signal for your buck boost converters, and also you can also use this module to control the servo motors. So thank you. If you like this video, please like it and subscribe to my channel. Thank you.